Okay, so for this video tutorial, I'll be discussing about converting decimal to octal, decimal to hexa or hexadecimal, and decimal and octal to hexa and vice versa. So instead of using the traditional way, which is dividing by 8 or dividing by 6, so let's use the shortcut method, which is by using the powers of 2, that is 1, 2, 4, 8, 16 up to 20, 48. If that's not enough, kindly add another digits among the powers of 2. Now, let's start first with decimal to octal. So, in converting decimal to octal, please do take note that the basis or the basic in conversion is by converting it first to binary. So the very basic is to go back in conversion of decimal to binary and binary to decimal. So for all this conversion, all the basis of conversion, we need to do it by converting it first to binary. So let's start. Okay. So the very first one is, let's say for example, 1, 2, 1, 2, 4, base of 8 to, wrong. That is 100, I should say, to base of 8. So decimal to, this is decimal to octal. So as I told you a while ago, we need first to convert it to binary. So after converting that one into binary, now it would be easier to convert that binary to octal. So we have 100. Among the powers of 2, which of them is closest to 100 but less than 100? That is basically 64. Then 100 minus 64, that is actually 36. So pasok pa rin ang 32. So 32 is included, so let's put 1 in there. So 36 minus 32, that would be 4. Then we have a digit of 4, so let's put 1 in here, and the rest is 0. Now, as you can see, this is the digit or the binary digit of 100 is 1100100 base of 2. Now, to convert that one into octal, we just need to group it by 3. Because a digit of octal, take note, a digit of octal is equivalent to 3 bits. Okay? A digit of octal is equivalent to 3 bits. So now, if we are to group that one, that is basically 1, then 100, then 100. Take note 1, then 100. 1 binary is equal to 1 decimal or 1. Then 001. Okay, ilagay natin dito ang 001. So that is actually equivalent to 4. So this is another 4. Now, the value of that one would be 4, 4, then this is 1. So now, this will be equivalent to 1, 4, 4 base of 8. Okay. So let's proceed. Let's try another example. Okay, so let's try another example. So now, the value of 100 decimal to octal is 144 base of 8. Now let's try another example. Let's say we have a decimal value 200. Okay, so we have a decimal value 200. So let's convert that one into base of 8. As I told you, the first thing that you should do is to convert 200 decimal into binary. Now, so converting that one, so we have 1 to 8 because 256 is beyond 200. Then 200 minus 1 to 8 is equal to 8, that is 82. Ah, wrong. It's not 82, that is 72. So 0 minus 8, that is 2. Uh, this will become 10 minus 8, that would be 2. This would become 9. 9 minus 2, that would be 7. And this is 0 because 1 minus 1 is 0. Now, next, is 64 less than 72? So that is basically yes. So we put 1 in that one. So minus 64. So this will become 8. So we still have a value of 8. Among the powers of 2, we have 8. So the rest is 0. Now, so this is the binary. It's not the octal. As I told you, we need to group them by 3. Sir, it's not enough. It's not a 3 digit. So you just put 0 in here because that has no value at all. So this will basically become 0, 0, 0, 0, 0, 1, and 0, 1, 1. The value of 0, 0, 0 is 0. The value of 0, 0, 1 is 1, and the value of 0, 1, 1 is 3. How did I get that one? By using this. So 0, 0, 0. So that is actually 0. Then next is uh, 0, 0, 1. That is actually 1. Then we have 0, 1, 1. That is 2 plus 1. That is 3. So the digits now is 0, 1, 3. So 200 is equivalent to 310 base of 8. Okay? Next, another example. So let's try a higher value. Let's say 500. So 500, convert that one into octal. So again, we convert 500 into binary. So we have 512 is beyond 500, so 256. It should be 256 because the number closest to 500 but lower than that of 500 is 256. So 500 minus 256, we have 4, we have 4, we have 2. That would be 244. Then we have 128. So 244 minus 128, that is 6. Uh, this would be 1, and this would be 1. So 116. Then we have 64. So 116 minus 64, that is 6 minus 4, that is 2. This will become 5. So we still have 52. Then we have 32. So 52 minus 32, that would be equal to 0. So 20. Then we still have 16. So 20 minus 16, that would be equal to 4. Then we have a digit of 4. So the rest is 0. And this is 1, then 0. Now, that is the binary equivalent. For us to convert it to octal, so we need to group them by 3. Okay? So the digits would be actually once that would be actually 111, then 110, then 100. 111 is actually 7. If we are to put it in here, 1, 2, 3. So 4 plus 2 plus 1, that would be 7. 110, that would be 6 because 110. So 2 plus 4 is 6. Then we have 100. So 100. So this is actually under 4. So that would be 4. So the digits now, so we have 100 is 4, then 110 is 6, and then 111 is 7. So the value of 500 to octal is actually 7, 6, 4 base of 8. And this is already the answer. Okay? Okay, so let's proceed with decimal to hexadecimal. So decimal to hexadecimal. So decimal to hexadecimal. So decimal to hexadecimal, that is base of 10 to base of 16. Now, let's give another example, which is, let's say, 542. What would be the value in base of 16? So 542. So if we are to look in this, so 1024 is beyond 542. So 512 is the closest number but lower than that of the number. So 542 minus 512, that is 0. This is 3, and this is 0. So we still have value 30 remaining. So 256 is greater, so that would be 0. The same with 128, 64, and 32. Because 32 is still greater than 30. Then we have 16. So 30 minus 16, that would be 14. Okay? So we have 8 is less than 14. So minus 8. So 4 minus 8 or 14 minus 8, that would be 6. Then 6 minus 4, and then that would be minus 4. Minus 4, that would be 2. And the last one is 2. So the rest is 0. Now, we need to convert that value into hexadecimal. In octal, a digit of octal is equivalent to 3 bits. Take note, a digit of octal is equivalent to 3 bits, while a digit of hexadecimal is equivalent to 4 bits. Now, we just need to group the binary value into 4 groups. So, 1, 2, 3, 4. 1, 2, 3, 4, and then this one. So, we just need to put 0 and 0. Now, this one, so the digits now will be, that would be 0, 0, 1, 0, 0, 0, 0, 1, and then 1, 1, 1, 0. So if we are to convert that one, let's say we have 0, 0, 1, 0. So 0, 0, 1, 0. So we have, this would be 2. The other one, that would be 1, 0, 0, 0. That would be 1. Now this one. So we have 0, 1, 1, 1. That would be actually 8 plus 4 plus 2. So this is basically 14. But as I told you, digits 10 to 15 is represented by the letters A to F. So A for 10, B for 11, C for 12, D for 13, E for 14. So this would be E. Now, the value of that one would be, we have 2, 1, E base of 16. That would be 2, 1, E base of 16. Okay? So, another example. Let's say, um, 1,500. So 1,500, 1,500. So what would be the equivalent in base of 16? Again, the first thing that we should do is to convert that one into binary. So find here, among the powers of 2, the number closest to 1,500 but less than 500. So that would be 1024. So 1,500 minus 1024, so that would be 6, this would be 7, this would be 4, 0. So we have 4, 7, 6. Okay? So that would be 4, 7, 6. Next, is 512 less than 476? No. So this would be 0. Then we have 256. So 0, 2, 2. So we have 220. So this is 1. So we also have 128 is less than that of 220. So this is 1. So we subtract 128. So 0 minus 8, that is 10 minus 8. So that is 2. Then 11 minus 2, that would be 92. Okay? So 64 is less than that of 92. So this would be 1. So 92 minus 64. So this would be 8, then 28. Then 32 is greater than uh, 28, so this is 0. Then we have 16. So minus 16, that would be 12. Okay, so 12. So 8 is lesser. So this is 1. So minus 8, that would be 4. Then we have the digits 4 remaining, that would be 1, and the rest is 0. So this is the binary digit. The next thing that we should do is to group them by 4. So this one, 4 digits, 4 digits, and 4 digits. You just need to add 0. Okay? So basically the digits is, so the digit would be, we have 0, 1, 0, 1, then 1, 1, 0, 1, then 1, 1, 0, 0. So this is 1, 0, 1, 0. You just add uh, the powers of 2 with 1 under it. So that is 4 plus 1. That would be 5. Then we have 1, 1, 0, 1. So that is 1 plus 4 plus 8. So that would be 13. So instead of putting 13, because this is already a 2-digit, so repeat, 10 is for A, B is for 11, C is for 12, and D is for 13. So this is D. Next, 1, 1, 0, 0. So 8 plus 4, that would be actually 12. And we represent it using letters, that would be C. So the digits now is 5, D, C. So, wag nyo pong ilalagay or do not put 5, 13, 12 because this is wrong. Okay? So that is how you convert uh, decimal to binary. Decimal to octal. You just need to convert first to binary, then convert to hexadecimal. And the last one, we have hexadecimal hex to octal. So if we are use hex to octal, the first thing that you should do is, that is actually hex to bin to oct. Okay? Remember this one. If you are converting hexadecimal to octal, so you just need to convert the hex first into binary, then octal. So example, CE. CE base of 16, what would be the equivalent to base of 8? So C is actually 12 and E is actually 14. So if we are to put that one in here, okay? So if we are to put that one in here, so E is 14, that would be 0, 1, 1, 1. And 12 would be 1, 1, 0, 0. This is E and this is C. So you write that one. So 0, 1, 1, 1, then 0, 0, 1, 1. Now this is the hexadecimal, the decimal value of that of CE. This is the binary value, I should say. This is the binary value of CE. Now we need to convert that one, this binary, into octal. So group them by 3. Okay, and that's it. So it would become 0, 1, 1, 0, 0, 1, then 1, 1, 0. 0, 1, 1 is 3, 0, 0, 1 is 1, and then 1, 1, 0 is 6. So the digit would be 3, 1, 6 base of 8. Okay, paano po nakuha? How did we get this one? Question is, how did we get that one? So you put it under here. So that would be 1, 1, 0. Then add the ones together. So 2 plus 1 is 3. 0, 0, 1. That would be 1. 1, 1, 0. That is 4 plus 2. So it would be 6. Okay? So another example. Another example of hexadecimal to octal. Okay? So let's say 1, 4, 8. Base of 16. Take note, that is base of 16 to base of 8. Okay, so what is the equivalent of 8 in binary? That would be, so 8 in binary, that would be 1, 0, 0, 0. 4, take note, that is 4 bits because we are talking about hexa. 4, that is actually 1, 0, 0. But we need 4 bit. So let's add 0 in here. Do not add in here because that would be wrong. Do not add in this part. Dapat dito po siya, sa left side. Then we have 1. So 1 is 0, 0, 0, 1. Now we put in here, so that would be 8 is 0, 0, 0, 1. Then we have 4, that is 0, 0, 1, 0. Then we have 1, that is 1, 0, 0, 0. The next thing that you should do is to group them by 3 together. So group it by 3. So 0, 0, 0, 0, 0, 1, then 1, 0, 1, and then 0, 0, 0. So 0, 0, 0 is actually 0. 0, 0, 1 is 1, and then 1, 0, 1 is 5, and then this is 0. So the value of 148 is 510 base of 8. And that's it. Okay, next. We need to convert octal to hex. Octal to hexadecimal. So octal to hexadecimal. If we are to convert octal to decimal, that would be actually octal to bin to hex. Octal to bin to hexadecimal. Okay, now, we give an octal value, let's say 71. Base of 8, we convert that one into base of 16. Again, we need to convert each digit to binary. So 1, that is actually, take note, if you are talking about octal, that would be, a digit of octal is equivalent to 3 bits. So that would be actually 0, 0, 1. And then we have 7. 7, Okay, if we are to put 7, ano natin makukuha ang 7? So, 4 plus 2 plus 1. So, that would be 1, 1, 1. Okay? So, 0, 0, 1, then 1, 1, 1. So, 71. If we are to write that one, so, the digit 1 first. So, 1, 0, 0. Then we have the digit of 7, 1, 1, 1. Then the next thing that you should do is to group them by 4 because we are converting it to hex. So you group it by 4. Okay, so this is 0, then that is 0. So 1, 0, 0, 1, that is actually 9. Then 0, 0, 1, 1, that is actually 3. How did we get that one? In here. So 1, 0, 0, 1. So 8 plus 1, that is 9. Then 0, 0, 1, 1. 2 plus 1 is 3. So the digit of hexadecimal would be, that is 39. Because this is 3 and this is 9. Okay, another example, last example. Let's say we have a digit of 1107 base of 8 to base of 16. So let's start with 1. Take note, so octal pa lang siya. So 001, tatlong digit. And 1, that is 001. Then we have 0, that is 000. And then we have 7, that is 111. Okay, paano nakuha po yan? So, basic conversion of 1, binary. So, 1, that is, ito lang siya, dapat. Pero dahil 3 digit po siya, nilagyan ko ng dalawang 0. Then, we have 0, 0 lang po yan. So, if we have 7 naman po in here. So, 4 plus 2 plus 1 is 7 actually. So, ito po yun. Now, this is the binary digit. So, 7 po ang nasa rightmost. So, siya po ang uunahin po natin. So, that would be 1, 1, 1. Then, the next is 0. So, we have 3 digit 0. Then, we have 1. That is 1, 0, 0. Then, we have 1, 0, 0. Okay, after doing that one, after converting to binary, we need to convert that one into hexadecimal by grouping them to 4. Okay. So this is 0, 1, 1, 1. That is 4 plus 2 plus 1. Kasi 0 naman na po ito. So 4 plus 2 plus 1. So that digit. So 0, 1, 1, 1. That digit is equivalent to 7. The next 0, 1, 0, 0. That would be, pag tinapat po po dyan dito, 0, 1, 0, 0, that would be 4. And then 0, 0, 1, 0, that would be 0, 0, 1, 0, that would be 2. So the value, eto po siya. Sulat niyo po dito. So 2, this is 4, and this is 7. So the actual value is 247 based on 16. And that's all. Thank you.